So we're given f of x equals negative x to the third times x plus 2 times x minus 3 squared times negative 2x plus 1 cubed. So it is in factored form. And we want to determine the end behavior, the zeros, their multiplicities, and then sketch the graph. So determining end behavior, when we are in factored form, we can't just look for the piece that has the highest exponent. We have to find it. So I'm going to take into account all of the leading terms of each factor and then anything else that's on the outside. So I'm going to look at negative x to the third, that's what's on the outside, and then times the leading term of the next factor, so x, and raise it to the power. So this is x to the first times I have x raised to the second power times this leading term is negative 2x raised to the third power. So I'll go through and simplify each piece. Negative x to the third just comes down. X to the first power is x to the first power. X squared is x squared. And negative 2x to the third, so the third power goes to both negative 2 and x. So negative 2 cubed is negative 2 times negative 2 times negative 2. So I get negative 8. And x to the third is x to the third. So now, multiplying all of my coefficients, so I technically have negative 1 times 1 times 1 times negative 8. So a negative times a negative gives me a positive, and 1 times 8 gives me 8. And then I'll add all of the exponents. So 3 plus 1 gives me 4, plus 2 gives me 6, plus 3 gives me 9. 4, 6, 9. Yeah, so 8x to the ninth power. So now to determine that end behavior, I do have my leading term. So the highest exponent is 9, which is an odd number. So odd indicates that they're going the opposite direction. One will be up and one will be down. My leading coefficient is positive, which makes my end behavior on the left, we're going down, and on the right, we're going up. All right, so there's my end behavior. Next, finding the zeros. So finding the zeros when I'm already in factored form, we'll just take each of the factors and set them equal to 0. So I do have an x on the outside, so this is x equals 0. X plus 2 equals 0. X minus 3 equals 0. And negative 2x plus 1 equals 0. So scooch down here, negative 2x plus 1 equals 0. And I'll solve all of those. So subtract 1 from both sides. I got negative 2x equals negative 1. Divide by negative 2. I get x is equal to a positive half. X equals 0 is already solved, so done with that one. X plus 2 equals 0. If I subtract 2 from both sides, I get x is equal to negative 2. And add 3 to both sides, I get x is equal to positive 3. So these are all of the zeros. So I know that the x, my graph will interact with the x-axis at all 4 of these points. Now, does that mean they'll cross or will they bounce? We have options now. The multiplicity of each zero will tell me whether my graph will simply cross the x-axis or if it will bounce off the x-axis. If the multiplicity is odd, I know it crosses. If it's even, I know it bounces. So the multiplicity comes from the exponent of each of the factors. So x equals 0 came from my first factor, which is x to the third power. So the multiplicity of x equals 0 is 3. 3 is an odd number, so I know that my graph will actually cross at x equals 0. X plus 2, its exponent is 1. So its multiplicity, scoot that up, the multiplicity is 1, which again 1 is odd, so I know this will cross. The factor x minus 3 has an exponent of 2, so that root has a multiplicity of 2. 2 is even, so I know that my graph will bounce off the x-axis at this point. And the last one, negative 2x plus 1, has an exponent of 3. Let's get that down. I have an exponent of 3. So the root that came from that factor, x equals a half, has a multiplicity of 3, which is odd. So I know that my graph will actually cross the x-axis at that point. So I have my end behaviors, I have my zeros, I have my multiplicities that tells me whether I cross or bounce. And so now I can actually sketch the graph. So I'm going to get a graph going. It's my x-axis, my y-axis, and I'm going to plot all of my x-intercepts and indicate what happens at each point. So I have x equals positive a half. Let me get some numbers on here. So I have negative 4, and this is positive 4. All right, so I have x equals positive a half, so it's in between 0 and 1 right here, and I know I'm supposed to cross, so I like to put a little c right there so I know what's happening. X equals 0 right here, and again I know I should cross, so I'm going to put another little c right there. X equals negative 2. Again, its multiplicity was odd, so it should cross. And x equals positive 3, so right here. Its multiplicity was even, so I know it should bounce. So I have all of my x-intercepts, or my zeros, and now my end behavior. So we determined that on the left I'd be going down, so on the left of the leftmost x-intercept I should be going down, and on the right I should be going up. So on the right of the rightmost intercept I should be going up. And now we're just going to trace through using our end behavior and crossing and bouncing as we go. Now, I have 4 x-intercepts, so I should not interact with the x-axis any more than 4 times. So I'll come up, cross at negative 2. I have to double back, cross at 0. Come back, double back, cross at a half, tight squeeze. Come back up, bounce off of 3, and go up. There's my graph. So my end behaviors, my multiplicities, zeros, and then the graph, all from factored form.